Lecture 16 then of Stanford CS193p, spring of 2025. And today is a bunch of miscellaneous topics that hopefully might help you with your final project. One is how to do shapes. Okay, we know how to do the built-in shapes, rectangle, circle. What if we want to do our own shape? Number two is multi-touch gestures. Okay, we've only done taps. It's the only kind of gesture we've done, although actually we have the scroll view and it's got drag to scroll up and down, but it's all doing that internally. So I'm going to show you how to do your own gesture handling. And then finally, I'm going to talk more about persistence. We know a lot about persistence because we know about SwiftData, but what about the file system and file formats like JSON and things like that? I'm going to go over those. So I'm going to do a little bit of slides, a little bit of demo, a little bit of slides, a little demo. And again, I will run out of time, and I will continue this in a recorded thing sometime later. All right, tomorrow, meaning sometime later is tomorrow. All right, so shape. Shape, as we know, is a protocol. Things behave like a shape. And we know that that protocol inherits from view, which means that all things that are shapes also behave like a view, which is kind of cool. And the examples of shapes, of course, rounded rectangle, circle, all these things that we have seen. So what do you do if you want to create your own shape? The shape protocol already does var body because it inherits from view, but it adds its own required thing, which is path in rect. So you have to implement this path in rect if you want to implement your own shape. And a path is a struct, and it has a lot of functions on it, like draw a line to here, draw a curve, a Bezier curve, and it even has things like, is this point inside of this shape? So you can do hit testing and things like that. But you mostly are just going to build a path here and return it, and that's how you're going to make your shape. This is best shown via demo. I'm just going to go in a demo and we're going to make our own shape. And the shape we're going to do is a diamond. It's probably about the easiest possible shape, but I'm trying to race through this stuff. We're going to make all of our pegs in our codebreaker be diamonds instead of, what do we have currently, circles or rounded rects or something. We're going to make them be diamonds instead. So we're going to implement our own diamond shape. So let's do that. Here's where we left off. Yes, we have circles for our peg shape. Where is our peg shape? It's down here in peg view. Here it is. Oh, right here, circle. And so we changed this to rounded rect at some point. And I'm going to change this to diamond. And this is great. This would actually 100% work, except for there's no such thing as a diamond. Diamond is not one of the pre-canned shapes, so I'm going to have to make diamond myself. No problem. I'm going to go up here, File, New, Template. And since a shape is also a view, behaves like a view, I'm actually going to say that I want to build a SwiftUI view. And it's going to have a # preview thing at the bottom for it and all that, which is great. So here we go, SwiftUI view. I'm going to call it diamond. It's my shape. It's definitely part of the UI here. All shapes and views are part of the UI. And now I'm going to get rid of this var body, and I'm going to say that this is a shape instead of a view. You can see right away it says, okay, great, but type diamond does not conform to the protocol shape, which of course it does not because it doesn't implement that func I was talking about. And I'm even going to do this fix it here, which is add stubs for conformance, and have it add that function for me. So I hit fix, it gives me this thing, and I just have to fill this out, and somehow I have to return a path here because you see this is returning a path, right? And if we look at this in the documentation here, let's go look at path. Here's path. It's got some various inits. I'm actually going to use this init right here, which takes basically a closure where you build the path and return it. So it's kind of a construction type of initializer. But if you look in path, look at all the things it has. Move to a point, add an arc, add a curve to a point, add some lines to a point, etc. You see what I'm saying? It's essentially 2D drawing. I'm drawing with lines, so I can draw the outline of a shape, and then it's going to be able to fill and stroke that. All that mechanism is just built in once I've done this 2D shape. So let's go draw a diamond here. Again, I'm going to use this path in version of constructing one here, and all I have to do is call functions on this path which add lines and move around, etc. Let's even make our thing so we can see what we're doing over here, because I have a preview that's showing the diamond. So I'm going to start by having my path here move to, and all these places we're moving to are points, and so we're going to use CG points for those. So I'm going to start at the top of my diamond. right up here at the top of this diamond. And the x value is the middle of this rectangle. Because this path in rect, I'm supposed to draw the diamond in this rectangle. So I'm going to go, for x, I'm going to go rect.mid-x. That's halfway across the rect. That's what mid-x means on a rectangle. And I want to be at the top. So what's that? Rect.what? Anyone? What? 0. I could say 0. How about min y? Right, because y starts at the top and gets bigger as it goes down, so I'm going to the min y. Let's keep going. Path.add line to a point. So let's go from up here, over here, down here, over here, and back up. So I'm going to go down to this point right here. So what is this point here? This is rect.min-x on the leading edge there, and y is rect.mid-y. Get our y up here too. Make sense? Now, how come I'm not seeing this line here? I started here and I drew this line. Anyone know why I can't see it? It's because I have to stroke it. The path that you build is just a conceptual path until you fill it or stroke it. Then you can actually see it. Let's go add the rest of these here. Path.add line to CG point x rect.mid-x again. And the y is rect.max-y. That's down there. And then path.add line to CG point x.max-x. And y is rect.mid-x. Right? And I'm actually going to use another thing here to close this path.close subpath. And that closes it back to where it was right there. And you can see I made a mistake. I said rect.mid-x, and that's why that's not here. This really wants to be rect.mid-y. So now we have a diamond. Notice it's not a perfect diamond, you know, like a diamond with equilateral sides there. We could make that by just saying diamond.aspect ratio 1, content mode fit. Fill is the default of a shape. But we could do stroke as well, dot stroke. See what's happened in there? So now I have this diamond. Now actually the rest of my UI, watch this, all works. Because I'm just using this diamond shape as my peg shape. If I go back here to peg view, see I said diamond, and it's just using it everywhere. Not only in my game list here, but if I go to a code breaker view, show this, playing the game, diamonds everywhere. Any questions about that? Now, another cool thing about these paths, they also behave like a view and behave like a shape too, for that matter. So it's possible I could take this path right here and go into peg view and actually use it right here. Just put it right in line. Since this behaves like a shape or behaves like a view, it works fine. But what about this rect? How does this path know what rectangle we're drawing in here? So I'm going to show you something that I've waited all quarter long to show you, and some of you jumped the gun and went and looked it up. But I intentionally did not tell you about this because there's some restrictions to using this view. But there's a special kind of view which you can use, which says, put a view on screen and let my views inside me know what size I am. We call this thing a geometry reader. So I'm going to put a geometry reader, and it has a view builder, but it gives that view builder an argument here, geometry in. And this geometry has some functions like, what's my frame? What is my bounding rectangle, for example? So we could use that to do this right here. So I'm going to take this path and put it in here, and I'm going to say, let rect equal this geometry proxy frame, and here's in local, that's my local coordinate systems. I could also do global coordinate systems, which is the global coordinate systems of the whole device, but I want to do local, obviously. And look, it works. So what's the problem with Geometry Reader? Why didn't I show you Geometry Reader before? Well, one thing about Geometry Reader that you have to understand, it is infinitely flexible in all directions. It's always going to take the maximum space available. It's like a rectangle. And a lot of times you put a geometry reader around something like a text or something like that, and you took a text which is fixed size and you made the text now be floating in some fully flexible space, and it gets all messed up. So it can mess up all of your layout here to be plopping this infinitely flexible view into the middle of the thing. So you have to know what's going on. Now, this still works here because look, we got aspect ratio right here, and that is constraining the aspect ratio of this infinitely flexible thing to be a square. And so it's working. Now, that also works here because we were enclosing an infinitely flexible thing anyway. Circles and rectangles and diamonds even are infinitely flexible. Geometry Reader, you got to be a little bit careful and really understand that you can't control its flexibility. It always wants to be fully flexible. But it is good then if you can get it to be the size you want, things inside can know what size they are and know what their frame is. And since we're on the topic of Geometry Reader, I'm going to show you a really popular thing that people have been asking. Let's go over here to UI Game Chooser. This little peg chooser down here, remember that when our game ends, it slides off the bottom. And then when we restart the game, it slides back in from the bottom. And let's go look at the code that does that. It's in Code Breaker view. Here it is right here. If the game is over, it's not there. And if it's not is over, in other words, still going on, it is there. And we have this transition, which is this peg chooser here. Let's go look at this peg chooser transition. That's over in our extensions over here. This is it. This offset. And look at that. It has a magic number, 200. And many of you ask me, how do I get rid of this magic number? I don't want a magic number in my code, which is really good impulse to not have it in there. So let's talk about how we would get rid of that. I'm going to take this thing and put it back over here so we can see it in all its grandeur here. And I'm going to say, how can I get rid of this magic number? Well, I can use that geometry reader to do it. But I actually need two geometry readers here. And the reason for that is I need to know the geometry of my whole screen, and I need to know the geometry of this so that I can find the difference between this edge and this edge. And that's how much I'm going to move down. Everyone understand why I need two geometry readers here? Now, some would say, oh no, you don't really need two geometry readers, you just need the one for this, and you can use the screen size for this. And there is a way to get the bounds of the entire screen, but I encourage you to not think that way in iOS, all right? I want you to think not about screens, but about scenes. Remember back here in our Codebreaker app, we had this var body of the app is some scene. And I didn't really talk too much about scene, but a scene is like a window on the Mac, or even on an iPad, you can have two scenes side by side in like a split screen. It's possible to do that. We haven't seen it. But a scene is really the collection of the entire UI of a window or of your app. And in iOS, of course, this scene that's in the app is the whole screen. But if I had the bounds of this scene, can we all agree that I would have the bounds of my device? And that would work even if I was a window in a Mac or if I was half of a screen in an iPad or whatever. So we really want the bounds of this scene. And the bounds of this scene are really easy to get with a geometry reader because it always fills the entire space. And that's the only restriction on geometry reader is that it fills the entire space. So let's just go here and say geometry reader, geometry in. We'll put this inside here. And if I do that, this is going to recompile, and it just works. No problem. Geometry Reader fills the whole space. The game chooser goes inside there and fills it. It's great. But now I can look at this Geometry Reader and know the bounds of my scene here, the scene's frame. And in fact, I'm going to pass that along to my game chooser and thus all the views inside it using what? How do we pass a value into the entire view hierarchy? Yes, @ environment. So let's do an @ environment here. So I'm going to say environment scene frame, I'll call my thing. And it's not this, it is the geometry's frame, this case in global coordinate system. So this is injecting scene frame into the @ environments of all the views in here. But of course, for this to work, we need to have an extension to our environment values. And we're going to do an @ entry here for it, scene frame, and it's a CG rect. And I'm going to set its default value here to be that UI screen thing I was talking about. So UI screen.main is the main screen that you're on, and .bounds is its bounds. So this is only a default value. Here we're injecting the actual value into our views. So now we have scene frame as an @ environment in all of the views inside my game chooser, which I can look at to find out how big my scene is. So let's go back to my codebreaker view and use that. I go here and just copy and paste it. It's almost the same as this. This is my scene frame. This is scene frame. And yes, my codebreaker view is not directly in my game chooser view. It's brought on by it, but everything that comes out from there all have these @ environments with it. All right, now that I have the scene frame, I can use that with the geometry reader around this to find the difference. So let's go here and say geometry reader, geometry in, put this thing inside there, that. And now I basically want to replace this 200 with the right offset based on those two geometry readers. And here's how I'm going to calculate that. Let offset equal the scene's frame, its max y. That's this right here. This is the max y of the scene's frame, this line right here. And I'm going to subtract from that the geometry reader of this guy's geometry right here, dot frame in global. We want them both in the same coordinate system, global coordinate system, dot min y. So that's this line right here, the minimum of this geometry reader. Now, this has done something bad. This thing has moved. Why did this move? Maybe you'll understand this the most if I put a little yellow background onto this geometry reader. This space right here is half of this space, because this scroll view, it's infinitely flexible. It uses all the space available. And this geometry reader is infinitely flexible, and it uses all the space available. So they're sharing the space half and half. So they're doing exactly the right thing here. This is the kind of layout problem you get when you start throwing geometry readers in there. You're like, what's going on here? So how do we solve a problem like this? Well, one thing I guess we could say is let's move this max height off of the peg chooser and put it on the geometry reader. Oh, that got somewhat better, because now it's only 90 high, but it's not centered anymore. Why is this not centered anymore? It's because the little peg chooser H-stack in there is just being plopped inside this infinitely flexible view that, yes, is only 90 high, and it's just left aligning it right there. What we really want is this whole thing to fit exactly my peg choices thing, so it'll go where I want it to be. And we can do that with our old friend aspect ratio. And what is the aspect ratio of this little peg chooser? Well, approximately it's 3 to 1. 3 across, 1 down. I say approximately because there's some little padding in here that actually makes that not true, but it's close. So I'm just going to say that my aspect ratio is a CG float, which is my games peg choices .count, content mode .fit, and look, it's going to fit this geometry reader right here to be that size. Let me put this in before it is. How about that? There we go. So now the yellow thing has been fitted down. So it is possible to take this geometry reader that wants to be big and using aspect ratio and max height and things like that, get it to be the size you want. Are you cool with that? So now let's see if this actually worked. Let's go run this, the simulator here. All right, let's go here. Actually, let's go to an easier one to guess. How about this guy? Let's go reds, because I have to now guess what the thing is, and I don't have my cheat anymore. All right, so it's red, red, blue, green, maybe? No, how about red, blue, green, red? Oh, okay. Blue, red, red, green. Okay, so now we should be able to guess it, right? So it is, maybe it's blue and then blue and, no, this can't be that, something like that, green, blue. I'm terrible at this game. Here, we can do this, watch this. We'll find out what the green is. Okay, so one of those is green. So green, red, blue, red. Okay, they're all wrong. Okay, so that means this one is this green, and this one, I guess, got to be red. This is red and blue. Woo! It worked. Now, it floated down there, and it didn't get all the way off. It kind of went down most of the way and stopped. Why did that stop there? Anyone want to guess why that stopped there? It's because of that safe area. You see this little bar down here that lets me drag up to switch to another app? That's a safe area. So back here in my app, where I did my geometry reader right here, I need to say that this view that I'm doing here ignores the safe area on all edges. So that way it's going to go all the way out to the edges. The idea here, again, is using these geometry readers can be valuable. It can be good to try and figure out what's going on, but you have some restrictions that you have to be a little bit concerned with. So is this what it was? There we go. See, it went all the way off, and when we restart, it comes all the way back on. And let's go ahead and get rid of the yellow. That was our little testing thing. One other thing I wanted to mention, by the way, over here in our peg view, remember when we replaced this with the geometry reader and the path? Look at this content shape. Content shape makes it so that when we tap on a diamond here, it only activates when we're inside the diamond. And that does work here for the diamond, but it doesn't work for this thing. So that's a good reason why we don't want to do it that way. Instead, we want this to be peg shape, so that this peg shape that it's showing matches this content shape that we're doing to restrict it. You see? It only was working before because peg shape happened to be the same as that path. But one good reason to make things into shapes is so that you can use them in arguments to things like view modifier content shape. So that's it for shape. Any questions on shape there? It would be kind of fun if you do your own shape in your final project. Hopefully some of you will find a way to work that in. Back to our slides. So that was our shape demo. Now we're moving on to talking about gestures. So gestures are all about getting input from the user. We know we can get input from the user like with a text field and also by tapping on things, but also sometimes we might want to swipe or pinch or things like that. These are called multi-touch gestures because you can have multiple fingers involved. It's 2-finger swipes and pinches and all that are multiple fingers. And SwiftUI pretty much takes care of all the work of watching the fingers to figure out, is this a swipe, or is this a drag, or is this a pinch, whatever. It figures that out for you. So your job is to attach a gesture handler to a view and then handle it. Like do something when that gesture happens. So the first part of attaching a gesture handler to a view, it's the .gesture view modifier. You just say whatever view, .gesture, the gesture, and the gesture has to be anything that implements the gesture protocol, like tap gestures and drag gestures, etc. Now usually we're going to put that the gesture thing in its own little var, right, inside of our view, var gesture. Type is some gesture, and we're going to return a gesture. In this case, I'm doing tap gesture with a count of 2. And if I do this code that you see up here, the colored code, then my view is going to start recognizing double taps. Because I said tap gesture count 2. So when I do a double tap, it's going to recognize it. Now it doesn't do anything because I only caused it to recognize those gestures. Now I have to handle it. So let's talk about handling gestures. And it depends on what kind of gesture that you're talking about. If it's a discrete gesture, you're going to handle it one way. If it's a continuous gesture, in other words, a gesture like a drag or something like that, it's a different way. For discrete gestures, those are gestures that happen all at once, like a tap or a long press. You just do it and it happens. There's not things moving as it moves along. For those, you just add .onEnded to the gesture. So there's that tap gesture from the previous slide, and I've just said .onEnded, some closure where I do something. Couldn't be simpler. That means when the double tap ends, I'm going to go do something. Now, for discrete gestures, we always just use the simple ones you know about, like dot on tap gesture. It's just so much easier to say dot on tap gesture than to do all that other business. But I've kind of introduced this so you have an idea of what that on tap gesture thing is doing behind the scenes. But let's talk about the real gestures here, which are these continuous non-discrete gestures like dragging, magnify, which is pinching, and rotation, which is a cool gesture. I don't know if you know about it. You put both fingers on the screen and you turn like a knob, and it'll tell you the angle of the turning. That's called a rotation gesture. For these gestures, instead of just having on-ended, you have another thing called on-changed. And the on-change closer has another argument to it, which is value. And that blue value that you see right there, it's different for every kind of gesture. So for a drag gesture, that value is where the drag started and how far it's gone, and even things like the velocity of the drag, that's all in that value. For magnify, it's mostly the magnification. So in a magnify gesture, when you first put your fingers down, the magnification is 1.0. If you move your fingers apart, now it's 2.0 or 3.0. And if you move them together, 0.5, 0.2. You see what I'm saying? So that's what the magnification gesture is telling you about. It also has velocity, I believe. And then the rotation gesture, the value has the angle of the rotation. How many degrees you have turned your knob, essentially.
Can you give an example of like an app that you use a rotation gesture?
The question was, can you tell me about an app that uses rotation? I'm going to do better than that. I'm going to show you in our demo how to do it. That's a great question. So let's do that. Let's sit down right now. And let's do rotation gesture. Since that was asked about, we'll do that one first. Here, my code breaker view. Right now, I choose my pegs by clicking in my little keyboard here. I'm going to make it so that I put my fingers down and turn a knob, and it rotates through the peg choices. Blue, red, orange, as I go around the knob. Make sense? So I'm just going to be able to put my fingers right on the screen and do that. First of all, when you put a gesture recognizer on a view, you really want to think about which view you want it on. Because the fingers are only going to be recognized if they're both in that view. So, for example, I would never want to put it on one of these things or in the selection. Way too small. I can't get both my fingers in there. So I'm going to put it on my entire view here. This entire V stack, if you do the rotation gesture anywhere in there, it's going to do the rotation. So where is that? That's this V stack right here. Okay, that has all my stuff in it. I'm going to say recognize in here my little rotation gesture, which I'm going to call my peg choosing dial. It's kind of like a dial. I'm turning a dial to get it. And then this peg choosing dial down here, var peg choosing dial, is of course some gesture. And I'm going to return a rotate gesture. Now, just doing this amount of code makes it so that it's recognizing that rotation now. But again, I don't do anything yet. To do anything, I need to put this on changed in here. Okay? And the on changed has an argument, which is the value. And for a rotate gesture, the value is the rotation that we've gone through. So it's pretty easy to convert that rotation from degrees, let's say 0 to 360 degrees, to a peg choice index in my peg choices. I'm going to say let peg choice index equal an int, the absolute value of the rotation in degrees. You can also get it in radians, but I'll do degrees, divided by 90. So I'm going to take that rotation, and every 90 degrees that I go around, I'm going to go to the next peg choice. Turn 90, 90 more, go to orange, etc. And I want to make sure I don't go outside the peg choices. So mod by game.pegchoices.count. So that's my peg choice index. I'm just going to have my guess pegs at the selection equal the game's peg choices at that index. Anybody have any questions about this code? Because that's all we need to do to make this work. This is a little bit questionable here. We might want to be asking our model to do this. We used to have, or maybe we still have, a function that does that, but just for expediency, we're just going to do this. So let's play. over here. Let's go to a game. How about this one? All right, so I'm trying to make a guess. Now, how do I put my fingers on my simulator here? Can't press on this, okay? You can actually do it with the Option key. If you hold down Option, ooh, look, you get two fingers right here. Now, I haven't pressed the button down, so nothing's happening, but I have two fingers. I could pinch, I can rotate. So here we go. Ready? I'm going to press the button down, which is like putting my fingers down, and then I'm going to rotate around in a circle. You see how I'm going around and around? And look what's happening to the selection. It's rotating. If I go backwards, it goes backwards. So that's kind of fun. It's not a very efficient way to enter your guesses versus clicking on the keyboard down here, but it's still kind of fun. So I'm going to take the time to go do another one of these, also just for fun. Before we start, I'm going to take this, kill that, and delete this, and start with some fresh games. Go back over here and run. I just want all my test games. We must have deleted one there or something. Okay, here they are, all back. Here I have this list of games, and this game summary is pretty tall. So I can only see 4 games at a time on my iPhone. But what if I'm playing this for months, and I've got hundreds of games on here, and I want to see 20 games in this list? So sometimes I want to see only 4 games, but I want a lot of information. I want it to be big, and sometimes I want it to be really small, not showing much information, but having a lot of games. What if I just added a gesture here, which is a pinch? And if I pinch down, it makes these things all small. And if I pinch up, it goes back to making them big and showing me more information. How are we going to do that? Well, I'm going to have this little view right here, which is my game summary view. I don't know if you remember that, but this is called our game summary view. I'm going to have it have different modes, compact mode, and then regular mode, and then a large mode. So let's go fix that first and just make that possible. Let's go to our game summary. Here it is. Can close this, make some more space over here. This is our game summary. I'm going to add a nice little let size, a size, and I'm going to have an enum size, which is case compact, and a case regular, and a case large. Dot there. These are the 3 different sizes I'm going to support with my pinching. Little compact, size, medium, and large. And all I'm going to do is modify my body here. And let's go ahead and make this have a default so that our preview stops complaining. Large. I'm just going to change my body so that it looks at this size var and does different things. For example, see this little thing where it says 0 attempts? I'm only going to show that in large mode. So I'm just going to say if size equals .large, then show this thing. Right? So this is large by default, but let's go change it to regular. And our preview shows no attempts. Same thing with compact. So compact is the same as regular right now. So what else can we do? How about this text where it says preview? What if we make that smaller in compact mode? So I'm going to say size equals compact. Make this just be body font, otherwise be title. So look, see, it got smaller. But if I go back to regular mode, now it goes back to larger size, and same thing in large. It's going to be the larger size. What else can I do here? How about this size right here? See this frame height of 50? That's the maximum height of these little diamonds. Why don't we say here, if size equals compact, then we'll go smaller, maybe 35, otherwise 50. So now if I go compact, then that thing will squish down. And we're getting smaller and smaller here. But what if I want really small? If I want really small, then I want that preview and those diamonds to be on the same line. In other words, I want them to be an H stack. How am I going to do that? Because look, this whole thing is in a V stack. I really need to somehow change that V stack to an H stack when I'm in size compact. So I'm going to show you a cool little trick to do that, which is I'm going to create a local variable layout equal to, if my size equals compact, it's going to be an H stack, but not H stack, but something called H stack layout. H stack layout is a struct that's used by an H stack to lay itself out. So I'm actually going to pick that layout versus a V stack layout with an alignment of leading, by the way. And instead of saying VStack right here, I'm going to say layout. So you can actually parameterize which layout you're using by doing this little trick. But you can see there's an error right there. And it's essentially saying, I don't know what type layout is. Sometimes it's an HStack layout, sometimes it's a VStack layout, so I don't know what this type is. And when we get a situation like this, there's kind of two solutions to it. Sometimes we can use any layout or some layout, right? Some of those protocol things we talked about, because these things do conform to the layout protocol. But here we're actually going to use a different thing called type erasure. So we're going to actually type erase these things to be any layouts. So any layout is a layout conformer. It conforms to layout, and it takes as its initializer right there something else that conforms to layout, and it essentially defers all the layout to it. And what doing this does is it makes layout over here be of type any layout. You see? So I've erased the types. But it still works because any layout knows to take the layout you gave it and pass all the layout decisions onto it. So this is just a little trick for configuring, and look what happened. See, I'm in compact mode. I have HStack, and here I'm going to go to regular mode. And now I'm going to get back to having a VStack. And then if I go to large, I continue to have a VStack, but it adds that 0 attempt. So what I'm going to do now is add a pinch that goes between compact, regular, and large as I pinch. Everyone understand what we're trying to do? So let's go over to our game list right here. This is where we have our game summary. And I'm going to specify its size to be summary size. So this is a var I'm going to have to invent that is the size I want it to show. Right? Because remember we added size right here to the game summary. It's an argument to it, and I'm just setting it here to something called summary size. So I need a var summary size, which is of type game summary.size, and sure, it doesn't really matter what it equals here. Now, this summary size, is this going to be @state in here, or what kind of var is this going to be? And actually, when I think about this, I actually need two vars here. This is an important thing to understand of this kind of gesture, this pinching gesture. I need two vars. Why do I need two vars? One var is going to be the summary size when I'm not pinching. When I'm not pinching, I need to know what size is, and that's going to be whatever size I left the last pinch. I did a pinch. If I pinched it down, when I leave, it's got to stay small. When I pinch it big, it's got to stay big when I stop pinching. So I need a static summary size for when I'm not pinching, and I'm going to call that one @state private var static summary size, and it's going to be a game summary .size, and I'll default it here to large. Now, what's the other piece of state I need? I need, when I'm pinching, how much magnification. Because as I'm pinching, I want the thing to be changing. I don't want it to wait till I'm done with my pinch and then show me. I want it shrinking down and zooming up as I pinch. So I'm going to have another @state, which I'm going to call my dynamic summary size magnification. And this is going to be a CG float. And it's going to default to 1.0. And I always want this thing to stay at 1.0 whenever I'm not pinching. Because what I'm going to do for summary size right here, that's this summary size here, so I'm going to make this computed property, and it's going to be my static summary size, essentially, conceptually, times the dynamic magnification. So I'm going to take whatever the last size that I was, and then as I'm pinching, I'm going to magnify it. Now, what's wrong with this line of code right here? This line of code has a serious problem. I'm multiplying an enum times a CG float. So that's just no good. You can't multiply enums times CG float. Or can you? Well, yes you can, because remember I told you that things like equals, equals, and even plus and times are all just static functions in classes and enums and structs. So I can add a new static function that does multiply between an enum and this magnification, and then I can choose compact, regular, or large, depending on how big the magnification is. And again, I'm kind of showing you something a little more advanced Swift here. We're at the end of the quarter, so you can handle some of this stuff. And I'm going to go add a times operator so that we can take a enum here and multiply it by this magnification. So let's go make this times work. I'm going to go down here, put it in this file. It's an extension to GameSummary.size because that's what we're going to be multiplying here. And it's just a static func, and it's called times. That's what it's called. And it has, as the AI is suggesting here, a left-hand side and a right-hand side. That's just what's on the left of the times and what's on the right. And the left-hand side here is self. That means it's a summary size. It also returns self, a summary size. And this right-hand side is what I want it to be is CG float. So by implementing this method, I've made it so that I can have times where the left-hand side is a game summary size, that enum. The right-hand side is a CG float, and it returns, the value of the times is an enum. How do we implement this? Well, I'm just going to switch on the right-hand side, switch on the CG float, which is another new thing I'm showing you that I haven't seen before, which is switching on a float. And I'm going to say if this is 2.0 or more, so this is a new thing for you. This is a range that means 2.0 or up to the maximum value, max float or something. This means a range of any CG floats that are 2.0 or more. In that case, I'm going to return the left-hand side, but made larger. And in fact, for 2.0, I'm going to make it even larger. So if you make a big pinch, 2.0, right, you expand all the way to 2.0, I'm going to make it really large. I'm going to take whatever it currently is and make it larger and then even larger. Now, what is this larger thing? Well, that's something I'm going to have to go implement on game summary size because that's what left-hand side is. Left-hand side is a game summary size, so I'm going to have to implement larger over there. Now, if you do 1.5 or above, then I'm just going to do larger. So if you pinch a little bit bigger, then I'm only going to go one larger. And similarly, if you go anything less than 0.35, then I'm going to go left-hand side smaller, really, really small. And if you go, let's say 0.5, left-hand side, a little bit smaller. And the default is that I'm just going to return the left-hand side. So if you're pinching and you're like at 1.0, like you just started, or you were just a little bit bigger, a little smaller, then I'm not going to change the size. But then once you go over 1.5, it's going to get larger. 2.0, really large. Back down to smaller, really small. So this is new syntax I'm showing you here. This would be a common way to do this. So we have to go implement larger and smaller, as it says here. There's no member larger. So let's go over to our game summary. This is size. We have to implement var larger. It returns a size. And we're just going to switch on myself. And I'm making it larger. So really the only thing that can be larger is compact or regular. Something that's large is already large. Not going to make it any larger by saying larger. So I'm going to say if case compact, then go to regular. Otherwise, the default is to go to large. And same thing down here with smaller, switch on myself. In the case that is large, I'm going to go down to regular. Otherwise, I'm going to go down to compact. So regular or compact, go to compact in smaller, and large just goes to regular. So that's all we need to do to have the infrastructure to add this new pinching gesture. So let's go add that pinching gesture. I'm going to put it on my game list because this game list right here is the thing that I want to pinch. So if you pinch up here, it's not going to work. It's only going to pinch if you pinch on the actual list, if both fingers are on the actual list in here. So where is that list? Go up here. It's right here. See this list? Double click on it. I'm going to put right after here .gesture. And I'm going to call this gesture my summary size magnifier because that's what it does. It magnifies the summary size. And let's go down here and say var, copy and paste here, copy and paste, and it returns some gesture. And in this case, we know it's a different kind of gesture. It's a magnify gesture. That's what a pinch is. And it needs an onChanged, and that onChanged, of course, takes a value. And for a magnify gesture, it's just the magnification. 1.0 gets bigger, 2.0, 3.0 gets smaller, 0.8, 0.7, 0.5. That's the value that we get here. This value that's provided to us as the fingers move. And all I'm going to do here is just set my dynamic summary size magnification equal to that value's magnification. So as I'm doing this, it's going to be changing this magnification, which is going to be causing our summary size to change the static summary size by that magnification there, because we're passing that here. So that's easy. And then what about when it ends? When it ends, I'm going to say that my static summary size now equals what it used to be times the value's magnification. The fingers lifted up, and whatever the magnification was at that time, I'm going to adjust my new static size to be that, because I'm not pinching anymore, so I want it to stay at that. But I have to be careful here also to take my dynamic summary size and set it back to 1.0. This is value in. Because if I don't set it back to 1.0, if I left it at what it was before, like 2.0 or something, then my static summary size will be off by that much. So every time I stop pinching, I need to go dynamic size it back to 1.0, which makes it so our static summary size is our summary size here. All right, let's try it. All right, here we go. Again, I'm going Option. Got two fingers, haven't put them down yet. Ready, here we go. I'm putting them down. And, ooh, look at that. See? As I put my fingers closer together, it goes smaller. And expand out, it goes back to bigger. And if I leave it small, now it's small. And if I go back here and say, make it bigger, makes it bigger. So is this good UI? It's not bad. It's actually kind of interesting. It's direct adjusting of the UI. If you thought it was important for users to be able to switch back and forth between this more information, bigger mode and this smaller, more lines showing mode, then this might be a good gesture for that.
I know for some accessibility purposes there may be certain gestures that users may do. How can the app distinguish between special gestures?
Yeah, so the question is, there's a lot of other gestures going on, even just simple ones, like we've got this dragging going on here. And you mentioned accessibility, which it has a lot of gestures, triple taps and all kinds of things. Now, the accessibility gestures, they try to make them so they don't interfere, because they are things like triple taps and things that you don't normally do. So they try to make it so that you can do most of your gestures without interfering, although you would want to make sure that you're not interfering with an accessibility gesture when you're doing that. But the other part of this answer is that SwiftUI is pretty good at seeing you start to make a gesture and then realizing, oh, it's not that one, it's this other one. So SwiftUI tries to really be good about that. I'm only showing the basics of gestures here. If you go look at the gesture API, you'll also see that there's other things where you can create, for example, simultaneous gestures, or gestures that have to be synchronized, where one has to happen first, like maybe a long press, and then the drag. So long press first, once that's recognized, then it'll do a drag. All that's possible as well. But it can be tricky, and you have to be a little careful if you start throwing all kinds of wacky multi-touch in there that you're not interfering with other stuff, for sure. So I think there's a couple of good examples of multi-touch, because one of them is the very straightforward rotation one, where we're just directly setting it based on the rotation. And the other one's a little trickier, where we've got a static thing that's set, and then while we're in flight, we're having to modify it, and then when we lift our fingers, it has to go back to the static one. Both of those are common patterns to have to do when you have multi-touch. Back to the slides here. We are going to now talk about persistence. So we know how to do SwiftData. Number one way to do persistence is SwiftData. But there's other ways. For example, putting things in the file system. You want to just store files in your file system. Your device has a Unix file system in there, believe it or not, an entire Unix file system. And you might want to store files in there. And there are some really great structs, file manager, URL, data, bundle, that let you get at the things in the file system. So we're going to talk about how to do that. Then there's iCloud. So iCloud is not your file system on your local disk. It's out on the network. Okay? It's a way to store things out on the network. Now, iCloud interacts with both your file system, kind of, and SwiftData. Now, with SwiftData, the way it interacts is when you create a project with SwiftData, you can flip a little switch at the beginning. You might have noticed it. It says, oh, make this work with iCloud. And then what happens is everything you put in SwiftData gets pushed up to iCloud. And that means that when your customer runs your app on any of their devices, they see all the data they've created on any of their other devices, which is a really cool feature. Documents they create, code breaker games. Now, we didn't flip that switch. We probably should have. We didn't. So that's one way iCloud works with it. Another way that iCloud works is the CloudKit API. CloudKit is a way of creating records and putting data in those records and storing them in the cloud, into iCloud. That one I haven't shown to you, and I'm not really going to show it to you. It's got a lot of async API, as you might imagine, because you're talking about storing on the network, and the network fails a lot and things like that. The iCloud that makes your SwiftData happen works in a different way, where all your changes to the SwiftData happen on your local disk, and then there's some server that runs on your iOS that's pushing it up to iCloud in the background, and vice versa. It sees something in iCloud, it pulls it down to your local device and updates your SwiftData there. So that's a very different API. That's why the SwiftData API is not async, even if you're using it with iCloud. But CloudKit does have a lot of async API that you have to deal with. So it's not that hard to create records in CloudKit and put them out there, but it's a little beyond the scope of this first class. I have to draw the line somewhere. And then there's a lot of third-party solutions that do this as well. Firebase and all these things, they will let you store data on the network and access it later. They're also going to be asynchronous APIs. And then the last, and definitely the least, when it comes to making things permanent or persisting them, is user defaults. And user defaults is really just like a glorified dictionary that doesn't go away when your app gets quit. So I'm going to talk about that briefly. It's really only for storing small things. It's not a really big deal. That's why I say it's last and least to talk about it. So let's talk about the file system here. I said it's a Unix file system that starts at /, but you can't access a lot of it. In fact, your app can only access the parts of this big Unix file system that's called your sandbox. All the Unix permissions and all that stuff are set, so you can't even see anything on the Unix file system except for the stuff in your sandbox. Now, why do we do this sandbox thing? Well, you can think of obvious reason, which is security and privacy. You do not want other apps to be able to look into what your app is writing and get that data. That would be incredibly insecure. And Apple is very serious about privacy, and so the sandbox is completely secure in that way. You cannot see anyone else's sandbox. But there's other reasons to have sandbox too, which, for example, one of them is cleanup. When you delete your app from your device, you want all your data to be gone too. All your SwiftData, all that stuff. And it's easy because it just deletes the sandbox when you delete your app. And also backing up, the same thing. When you back up your sandbox, it knows to back up everything in the sandbox with some exceptions. There's some things in your sandbox, if it can get it from somewhere else, it's not going to back it up. But all the other stuff that you're creating, data that you're creating, it knows to look in the sandbox and back that up when it does its little iCloud backup. Now, what's in this sandbox? It's very important to understand that there are specific directories, specific folders in this sandbox, like your application directory. This is where your executable is, or if you have JPEGs or even videos or something that ship with your app, they're all going to be in this application directory in your sandbox. This is read-only, so you can't go and modify your executable on the fly, right? This is a read-only place. Then there's another very important folder called the Documents directory. This is where you store data you collect from the user that the user perceives as a document, conceptually. If we didn't store our codebreaker games in SwiftData, we'd probably store them in the Documents directory. Because I think the user perceives a given game as a document, roughly speaking. But then there's other things you might collect from the user, maybe profile information or something, settings, stuff like that, that the user doesn't perceive it as a document, but it is from the user. That goes into application support. So that's where you would store that. If you're going to store it in the file system, a lot of times settings and stuff, you might store them in SwiftData, but if you're storing it in the file system, that's where they go. And then there's other directories like the caches directory. This is a directory that is not backed up. So when you back up to iCloud, anything you put in caches directory, not backed up. And there's a bunch of other ones. You can find all these things by looking in URL, the struct URL. It has these statics for all these various things, and it's very important you need them because You always start with one of these. This is the only way to access your sandbox, is to start with one of these URLs. Now, after you get the URL you want, now you start appending path components to it, either folder names or file names. And you do that with the URL method, appending path component, or appending path extension if you're talking about an extension. And doing that, you build up the path that you want. But notice, you can only do it with appending, so you have to start with some URL, and the only URL it makes sense to start with is one of your sandbox URLs. So that's why it's basically impossible to write or read outside of your sandbox. Now, URL, in addition to having these nice appendings and the built-in sandbox URLs, it also has some nice functions like, is this a file URL? Because remember, URLs are used not just to access files, but to go over the internet, HTTP URLs and all that. So you can ask it, is this an HTTP or a file URL? And it also has this great function here, resource values for keys. You give it certain keys like creation date, is directory, file size, and it'll tell you that information about that file. How big is that file? When was it created? Is this file a directory? All that stuff you get from URL. URL is really your go-to portal to accessing the file system. Now, how about reading and writing to the file system? How do you read and write stuff to the file system? You mostly do that with data. Remember data, I talked about it before, it's a struct, it's a bag of bits. Unstructured data, just a big buffer of bits. And there is a way to have an initializer here for data which points at a URL and just gives you all the bits in that file. That's called contents of, data contents of, and it's got some options there which we really don't pay much attention to. This thing has a bit of a problem if your URL is not a file URL, which is that it blocks. So if you call this thing, which is legal, with a URL that's an HTTP URL, it will block. Your app will freeze. So we don't like to really use this, and you would never use this if the URL you're passing might be an HTTP. Never would you use this thing, because we never want to block the main thread. Now, maybe if we were running on a different thread, we might use this, but there's actually a better way to do all that, which is this way. Here's an async way to get the contents of a file as a data, which is URL session.share.data from URL. You see the yellow part of this down here. And this is great. It goes out even if it's an HTTP URL, and it gets that data and brings it back to you and gives it to you as a blob of data. But you can see that it is async, so you have to do await, which means you can't execute it in a normal execution environment. You need to be in an asynchronous execution environment, which means you need to be in a function that's marked async or in a task closure, as we've talked about. The data from URL returns a tuple there. Everybody knows what a tuple is, I hope, from your reading. But the tuple contains the data, which is a data object there, a data struct, and also this thing called a URL response, which is like the headers, the HTTP headers and stuff that came back. We almost always just ignore that stuff if we're just trying to suck information off of the internet. So this is the thing you're going to use if there's any chance that the URL that you're using might be a network URL. And URL session is something worth going and looking at. It has a bunch of other nice functions for pulling things off of URLs. There's also mechanisms like, remember in Words I did that for URL.lines, and I did the await in the middle of a for loop. So lines is in URL, and it's an async way of accessing it. That's a really cool way to do it because it does it line by line. A lot to look at in URL session, but this is the basis way to just grab data from a URL. Now, how about writing data to a file? You want to create a file in the file system? Well, you can do that with data's write function, write to URL. The options here, we actually do use more, like dot without overriding will make it that if you try to do this write and there's already a file there, it will fail. Notice that this function write throws. In fact, almost all of these things that have to do with the file system, they throw. So you can do a lot of do catches or try question marks around all of these things, reading and writing from things in the file system, etc. In addition to URL and all the stuff it can do, there's a few other utility things you should know about, like File Manager. File Manager can do things like copy files, delete files in the file system. It can tell you whether a file exists at a given path, that kind of thing. A lot of this stuff is in URL, but some of the things like copying files, this is where you go. File Manager has a default instance of it, FileManager.default, that you can use to access these things. I would always say look in URL first to see if you can find what you want to do, and if not, go take a look in File Manager. Another one is Bundle. Bundle is an awesome way to access files in your application directory. So these are usually files that you've shipped with your app, like JPEGs or whatever, and what's great about Bundle is it's localizable. So you might have things that you ship in your app, like images, that people in France or people in Japan want to get a different image, because maybe that image has to be localized, and Bundle will automatically do the work of figuring out what locale am I in, and it'll look in the right directories inside of other directories to find your localizable resources. So I'm going to use Bundle in the demo as well so you can see how to use it, but it's a great way to access the file system. Mostly what you do with Bundle is get URLs. It'll give you URLs to various resources inside of your application. Now, we only know how to write to the file system basically by writing raw data. That's not really very useful. Mostly we want to take structs and classes and write them to the file system, right? If we're not making them into @sign models and put them in SwiftData, and we want to store them, then maybe we want to put them into files. So somehow we have to take our structs and classes and turn them into a data. So we can say data.write to URL and put it in there. And the main way we do this is with Codable. Now, I already mentioned Codable in SwiftData. If you have a var and it's not of one of the right types, one thing you can do to make SwiftData store it is make it Codable, and then SwiftData will basically bundle it up into a little data and stick the data into your database. So you already know about Codable. So now we're going to talk a little about the details of Codable and how we actually make it work here. To make a data blob out of something, you got to make it codable, and it's sometimes really easy. You just mark the struct you want codable, and you cross your fingers, as we've talked about before, and you hope that Swift can synthesize that conformance for you. And as long as all your vars are codable, it can do it if it's a struct. Same thing for enums, as long as the enums associated data are all codable. But if your vars aren't codable, or if you're a class, then you need to implement your own implementation of Codable. And I'm going to talk briefly how to do that, but honestly, you're going to use AI usually to do that. You're going to say to the AI, write me an extension which makes this struct codable, and it's going to go do this work for you. But I want you to understand the kind of code that's coming back from an AI like that. Now, a lot of built-in standard types, like strings and dictionaries and arrays and all those things, they're codable, of course. So if you have vars inside of your struct that are these things, it's likely that you'll get some free synthesis there. Even things like CG point and CG size, those kind of things, they're all codable. What if it's not codable? What if you can't get this free synthesis? It's not one of these basic types, etc. How do you implement it? This is what it looks like. You have to do two parts of it, because the Codable protocol is really two other protocols, the decodable and the encodable protocols. And so you have to be able to both do encoding and decoding. And the decoding is done with an init. So you're going to have to add an init to your struct or class, and it's called init from decoder. And it's going to give you this thing called a decoder. And notice that it throws. So you could do things inside there that are trying things if you wanted to. And it would just throw back out here. One thing to be a little tricky about here is if you're adding this init from in an extension to a class, you have to mark it convenience. Hopefully you all read your last reading assignment so you know about convenience versus required. And if you do that, then you have to make your class not be subclassable by marking it final. And I'll do this in the demo so you see what's going on there. So it's a little tricky when you're adding this init from decoder by extension to a class. You have to do convenience and make your class final. Now on the other side, the init is obvious. It takes the ball of stuff and it decodes it back into initializing your struct. The encode is just a function. You say encode to encoder, and it turns it into a blob. So let's talk a little bit about how these work. Essentially, inside the decoder and encoder that you're handed, you're going to save and restore all of your vars. One line of code per var. And they both work very similarly in that they have a var. The encoder and the decoder has a var called container. And you just grab that container and you start using it to decode or encode your var. So here's an init. See, I've done self init right there because I'm a class. If I was a struct, I wouldn't have to. And I'm getting the container, the first yellow line, container equals the decoder's keyed by container. Now this coding keys purple thing right there is just an enum that has one little case for every one of your vars. That's what the coding keys is, and I'm going to show you that on the next slide. And then you just go through for each of your vars, and you decode here by saying that your var, so name in green right there is one of my vars, equals container.decode, its type, which is a string, my name is a string, for key.name, which is one of the enum cases in coding keys, the purple coding keys. So the blue enum thing is in the purple coding keys. You just do that for every one of your vars to decode. And encode is the exact opposite. You get the container, and for every var you say encode my var for the key.name or whatever, your coding keys entry. So this is what you're going to see when you ask AI to generate conformance. It's going to generate these two things, this init and this encode. And it's also going to spit out these coding keys. So let's look at coding keys. Coding keys is just an enum, but it has two requirements. One, it has to be a string enum, so you have to say coding keys : string. Remember we talked about enums can be string or int enums. And then it also has to conform to the coding key protocol, which is really just a marker protocol. It doesn't actually have any requirements in there for you to do anything. And then you just list your case name, case foobar. These are just the little cases for each of your vars. And you can alias them by like saying foobar equals foo. We're going to use this Codable to generate things like JSON, and when we do, it could use that foo as the key inside the JSON. And in fact, let's talk about JSON. We're running out of time here, but we're going to go real fast and finish the slides, and I'll do the demo afterwards. Here's a typical struct, my type. I've made it codable. It's got a date and a string and then some other thing, which has got to be codable as well. And this is what the JSON would look like. Raise your hand if you know what JSON is. You've seen JSON before. Okay, everybody, great. So it's generating that JSON. So what we want to be able to do is take any codable struct and generate JSON from it. So how do we do that? Really easy. I have an object, my type. My type is codable. I'm just going to say let JSON data equal JSON encoder dot encode that object. And it is going to take that object, since it's codable, and make it up into a JSON data object. And it throws because it's possible for your little encode functions to throw. That's what it can throw. And JSON, of course, is a string-based thing. It's not data, it's a string. So you can then turn that JSON data that you got back from the JSON encoder into a string by using this little string initializer, string data. Encoding is UTF-8. That's a Unicode 8-bit format for text. JSON is always at UTF-8. And you'll get the string. And you could also, if you didn't want to do that, just write the data straight out to disk. Did JSON encoder.encode object, that returns something of type data, you see, JSON data is type data. You can just write it out to the file system directly using write that we talked about. And then when you read it back in from the file system and you want to turn it back into one of your classes, you just use a JSON decoder. JSON decoder, decode. When you're decoding, you have to say the type you think is in there, myType.self in this case, but that could be something like array of string or array of myType. It can be anything there, .self. And you give it the JSON data, and it will create it using that init you saw on previous slides there, and reconstruct your object. So that's how you can take your object, turn it into a JSON data blob, and then turn it back into your object. Notice I'm doing try question mark down at the bottom, but oftentimes we will do catch around the thing at the bottom, because we might be looking for malformed JSON that doesn't have the right keys or values or something like that. And the JSON decoder throws a lot of errors that are very specific about what went wrong. Last thing here, real quick, user default is this simple persistent dictionary. You get it by saying user defaults.standard. It gives you an instance of user defaults that you can use. You store data with this one function, .set. Set takes two arguments. The first one is the thing you're trying to store. The second thing is the key to store it in. This thing that you're trying to store has to be what's called a property list. A property list is not a protocol or a concrete type or anything. It's just an idea. And the idea of a property list is it's got to be a string, an int, a double, an array of a property list, or a dictionary whose keys are strings and whose values are property lists. That's what a property list means. So that's the only thing you can put in there. Another one is data. So you could take codable things, turn them into JSON, and put them in there if you want. But you're rarely doing that because you're only putting usually small things in user data, not big structs that you're codableizing, although you might have a small struct that you're codableizing. There are also convenient functions like set double. Set double will at least type check the argument there. And these 4 key strings, like some key in green, that's global to your entire app, so you've got to namespace them yourself. And getting the data out, there's special functions for each type: integer for key, data for key, URL for key, string array for key that will give you back the data. And they're all optional, and they'll return nil if there's nothing in the database, or if the thing in the database is the wrong type. It's not an integer, it's a string or something. Now, I'm just flashing by this next one, which is, what if you had an array and the things in the array are not strings? Then you're going to get an array of any, and any's in red. Just don't even, I'm just going to go on the next slide, because I don't want you to think about any. Don't do it. Don't put arrays of things that aren't strings into user defaults. If you use any, you're going to have to learn about things like the as operator, which you read about, but you probably didn't quite understand what's going on there. So a good way, if you needed to put an array of things besides strings in there, put it in a struct, make it codable, and put that in there, and then get it back out and uncodable it. All right, that is it. So what I'm going to do is this demo. I will do it offline. The persistence demo is really going to consist of 2 parts. One is we are going to add a little button right here that saves this game. And of course, we don't need that at all. We have SwiftData. Our games are all automatically saved. But I'm just doing this as a demo to show you how we might save this game as JSON in the file system. And then the second thing I'm going to do is make it so that in our app here, we have these sample games, which we currently add in code. I'm going to make it so we add these sample games by loading up sample games from JSON files in the file system. So that way you're going to be able to see writing to the file system and reading from the file system in 2 demos. Now for both of these things, we're going to need to be able to read and write JSON, so we're going to have to make our code breaker and our code be codable. But first, let's take a look at that code for putting a save button here. Let's go find where we put these buttons. It's actually right here on screen. Here's the restart button right there. And here is our elapsed time toolbar item. So we're going to go here and add another toolbar item. I don't really care where you put it. And it's going to be a button called save. It's going to need a system image, especially since it's in a toolbar. We'll call it square and arrow down, I believe is a pretty good one for saving, and you can actually see it happening right there. And when we click on this button, we're going to write a JSON of this game out into that documents directory. That is going to be our goal here. This is going to take a surprisingly little amount of code. The first thing we need to do is take our game and turn it into a JSON. So I'm going to say if I can let JSON equal trying to use a JSON encoder to encode this game. So I've got this JSON data. If this is successful, I'm using try question mark here. Then I'm going to make a URL to the place that I want to save this thing, and it always has to start with somewhere in the sandbox. So I'm going to say let URL equal URL struct there, documents directory, append a path component, which is the game's name. And then let's append a path extension, which is JSON. And by the way, when you're appending path extensions, you do not need the dot. It will add the dot for you. And finally, I need to write this JSON that I created from this JSON encoder here out to this URL, which we can do by saying try JSON.write to URL. And that is actually all we need to do to make this save happen. We have a very important error here, which is that this game is not codable, and that's why it's saying instance method encode requires code breaker conform to encodable, which is part of the codable pair. So we need to go make this codable. So let's do that. Going to go over here to ChatGPT. I already asked it a little earlier. Write an extension to the Swift class, which makes it conform. Here is my code breaker, and I did the same thing down here for my code class right there. And it generated this thing with the coding keys, and then the init, and then this encode. And so I'm just going to bring that over here by going File, New, File from Template, to Swift file. It's going to be called Codebreaker plus Codable because I'm adding Codable conformant to the Codebreaker and code. And this is part of my model. This is not a UI thing. So I'm going to create that. Here it is. This is the code that came from ChatGPT. And you can see it's doing all those things we said, but it actually has a little bit of problem here. Look at this red. It's saying initializer requirement can only be satisfied by a required initializer. So this is supposed to say required, but we can't do required because we're in an extension. So we have to do convenience, but since this has to be required, one way we can get around this is that convenience will satisfy required there, as long as this class code is not subclassable. We're going to go back here to code. Here it is. And I'm going to change this to be a final class. That's what this keyword final means on a class. It means you cannot subclass this. You can kind of see why that satisfies this. You've got this init, and you don't have to worry about a subclass coming along and overriding some other required init and then do an end around on this init right here. Now, the other thing is this is a class, so I need to initialize it first before I start setting all its vars from this container that I get from my decoder here. So we need an init with no arguments. That's pretty easy to do too. I'm just going to add an init with no arguments there. And to do that, all these things have to have values. So this one, we'll set it to have this value right here. And that's fine because the other init is just immediately going to set the pegs anyway. So it's fine if it starts out as an empty array there. I think we're going to have the same problems up here. Yes, we do. This is convenient init thing, so we need to go to code breaker. It needs to be made a final class, and we're also going to need an init here. Let's see what we got. Name will need something. These all have values. Oh, this one will need something like that. Okay, we've made our init right there. Hopefully, if we build, it should compile with no problems, and it does. So now we have this code breaker with its coding keys and it's init and it's in code. And we've got code with its coding keys and it's init and it's in code. So this is the code it takes to make code breaker and code codable. Everything should work, right? We would think everything should work. Let's go ahead and run. Back just so you can see this is the code we're trying to test right there. And so let's go to mastermind here. Maybe we'll even make a guess here. Guess. Oh no, it looks like we've broken our code breaker here by doing this codable thing. What the heck is going on? My guesses aren't working. Well, I actually think that what's causing this problem is that we made code codable. And if you remember that when we have a model and one of our vars can't be made into a model var, one of the solutions is, oh, we'll just make it codable. And another solution is to make it an outside model. And with code, we made it an outside model, but we've also made it codable. And I think SwiftData is a little confused, especially with this guy right here, whether it should be using codable to save this or outside model. Obviously, it should be using outside model. I see SwiftData get confused about this with relationships like this. These are too many relationships. An array is many of these codes when you don't have an inverse relationship. So we're going to add an inverse relationship to code. That basically means that code is going to have a var called game, which is a code breaker, and this thing has to be optional right here. And this is a back pointer to my game. Now, we don't need this. None of our code anywhere actually looks at a back pointer from the code to the game. We don't really care what game a code is in, at least right now. But this back pointer does seem to make SwiftData behave a little bit better. And to do this, we need to set the inverse here as code.game. And that tells SwiftData that this is a one-to-many relationship and the back pointer is this game. Now, like I said, SwiftData seems to behave better when there's a back pointer like this. So let's try it and see if that did fix it. Here we go. All right, back in Mastermind. Let's take a guess, cross our fingers. Woo, it's fixed. So this is working again. So now I have a game. It even has a couple of guesses. And we're going to hit this little save button to save it. Ready, save. Now, hopefully that did this code right here, and it turned that game into a JSON and wrote it out into the documents directory with the name mastermind.json. Hopefully all this worked. How can we tell if this worked? Well, there's actually a way that you can go look in the documents directory of an app as long as it allows it. And how do we allow it? We're going to go to our project settings over here, and we're going to go to this tab. See, there's these tabs. We're going to the info tab right here. And these are some of the settings. These settings in here often are allowing permissions for things, like if you're using maps or location, maybe there's a little explanation why you want a certain access. All that stuff is in here. So if you're reading your documentation, doing your final project, and it says, oh, add an info.plist, this is a P list, a property list, add an info.plist entry for doing something, this is where you go to do it. Now, the way you add one is you're going to right click on it and hit add row. And then there's a whole bunch of different things here. A lot of them are privacy oriented. You see all these privacy things in here. And the one we want is actually called supports document browsing. Here it is, supports document browser. And we're going to set that to be yes. So supports document browser, yes, just says to the system, yeah, I'm going to allow the user to look at the files in the document directory from outside the app. So let's rerun again. And I don't even have to do anything in the app. The very fact that I've installed an app that has that info plist entry means that I can do that. And one app I can go look at the document directory here is this app called Files. And if we go here to Files and go to on my iPhone, here is the code breaker. This is code breaker's documents directory. And if we click in there, woo! It did it. Here's our mastermind. And if I double click that, it's opening it in Safari right here. And this is what a JSON of a codebreaker game looks like now that it's codable. You can look in through here and see all the things going on in here. Like here's the name, mastermind. That's the name of this game. And then here's the elapsed time. Here are the peg choices, these 4 things. Here's the attempts down here. So there's one attempt there. There's another attempt right there. It's pegs, all that. So this is a string-based encoding of all the aspects of this. And this is exactly what we can do with JSON. Let's put another one in here. Let's go do undersea. I'm going to make no guesses on undersea and save that. Now we're going to go back to files. And there it is, undersea. Click on that. Here it is. Has a lot less stuff in here. That's pretty cool. We can look in there and we know that this is working. And I'm actually going to use the fact that we have these 2 files here to transition into my next thing that I want to do, which is I said that I wanted these games right here. Instead of loading them from code, I want to load them up out of JSON files in my bundle, in my app. So the first thing I'm going to do is actually move these 2 files into my app. So let's go over here and take this out of full mode right here. Now I can't pick these up and drag these because this is on a different device. This is on my simulator. Now my simulator is running on my device. And actually here's a little trick. If I click on one of these and then look at the URL that Safari is opening, it's down here. And I could actually copy this URL, go to my Finder and say, go to this folder, paste. I have to go to the actual JSON right there. We can go to the folder. Here it is. There's those 2 files. So I'm actually looking at in my folders that are on my Mac that this little simulator over here is running with. So here they are. So I'm going to take the 2 of these files and I'm going to drag them into Xcode over here. Well, actually, I can't do that because I need to open this because I want to drag them in here. Let's make a new folder. Let's call this sample games. We're going to put these files inside this sample game. So let's go back here, grab these things, go over here in sample games. And yes, we want to copy the files, please. Here they are. And we can even look in them here in Xcode. That's them. We could even edit them here in Xcode. Like, let's change this mastermind to be something else. Where's the name? Mastermind. Here it is. Name mastermind. Call this mastermind JSON. It's the JSON version of mastermind, and we'll do undersea. Where's its name? Oh, right here. Undersea JSON. So these files are actually in our application bundle, same place that our executable is, puts all these random files or assets and things like that in there, and we can go find them with this bundle thing that I was talking about. So let's go do that. Where do we load these up? I think it's in our game list. Yes, in our game list is where we have the code that loads up. Here it is. This is the code we load up to add sample games. And I'm just going to get rid of all of this code. This is the code that inserts these games. Get rid of that. And instead, I'm going to replace this with going out, looking in my bundle, getting the URLs of those things, creating data for them, JSON data from them, decoding them back to being games, and then putting the games in the list. So again, surprisingly small amount of code involved here. First of all, let's actually do a for loop, for URL in my sample game URLs. And I'm going to find every single one of these sample game URLs and go through each one and try and load it. Let's go down here and do a var for the sample games URLs. And indeed, it is going to be an array of URL. There's a cool little function in bundle called bundle.main. That's my main bundle. Paths for resources of type. And I just want JSON files. You can also specify in directory. This in directory lets you narrow down your search inside your bundle, but I want to search everywhere in my bundle, in all directories in my bundle. So I'm going to say nil here. Now, this is great and it's doing the right thing, but paths returns an array of strings. They're the string paths to it, and we want these to be URLs. So I'm going to map this to URLs, file URL with path $0. That turns it into a URL. And that's what I want here. Got an array of URLs. So this is going to find all the JSON files in my entire bundle. And I'm just going to go try to open each one as a game. And maybe there's JSON files in there for some reason that aren't games, but the ones that are, I'm going to put in as samples. All right, so how we do it? I'm going to let a tuple here, JSON, and I'm going to ignore that URL response that we saw in the slides. And I'm going to say URL session dot shared data from URL. So this is the asynchronous one here. So we obviously have to say await, and also this can fail. So we also have to say try. So now that we're saying try, I got to put this thing in a do catch. So I'm going to go do catch right here, and I'm going to catch the error and say couldn't load sample game from JSON file at that URL, and then I'll even print out the error's localized description. That's going to print out on the console. That way I'll get a chance to see if the thing is failing. And you can see it's saying async call that needs to either be in an async function or it needs to be in a task. So let's go ahead and make this an async function. This is definitely going to do something that's asynchronous, which is to load these things up. So that's fine to make this whole thing be asynchronous. Now that I have my JSON data, as long as this try succeeds and it doesn't jump down to here, we're going to have our data. Let's go ahead and let a game equal a JSON decoder, decoding into a code breaker.self. That's what we're looking for from JSON. So we're going to try and decode it. Now, this actually needs a try because decoding can definitely fail. Just think if your JSON file had a syntax error in it or something, you would definitely need to throw an error or whatever. And then we come down here and we get to see what that error is because we're printing out our localized description. So if this doesn't throw, though, then this will be successful and game will be set. And so now I'm just going to ask my model context to insert that game. And maybe we'll even print out loaded sample game from URL, just so you can see it on the console that we successfully did this. And that is it. That is all that's required to go through all the URLs in our bundle and try to open them all up as games to be our sample games. Now, to see this in action, we're going to have to go back to our simulator right here and delete our code breaker because it only loads the sample games when there's nothing in SwiftData. So I'm just deleting that, deletes all at SwiftData. Now we can go over here and run, and hopefully we'll just see these two games. Oh, no, we have a problem. Async call in a function that does not support concurrency. And sure enough, I'm trying to call add sample games, which I made async right here, trying to call that from on appear. So this is not any kind of asynchronous execution context. And so how do I do this? Well, this is a great place to use that task thing. I told you about task in the slides last week. Task is like on appear. It gets fired up when the thing appears, but this is running in a asynchronous execution context. So we can do await here on this add sample games. Now, this is running on the main actor. So this is main actor isolated, this line of code. So when we go down here to add sample games, all this is going to be running on the main actor, until we hit await. Once we hit await, then we're going to pause, and other code from the main actor, like processing, touch events, or whatever else needs to happen on the main actor, is going on, while this goes off and does it on some other actor or in some other queue somewhere. We don't know where it's running. We don't care. It takes a long time, whatever, it doesn't matter. Eventually it comes back. When this finally does return, then we continue running here again on the main actor, because this whole thing is on the main actor. There's no more awaits, so we run all the way to completion off the end of this, and we're done. So that's how this main actor stuff works. And we want this on the main actor, especially because we're going to do this model context insert. Whoa, we definitely want that to be on the main actor, because that's part of our environment that was passed in here. And we want all the accesses to this model context to be synchronous. Wouldn't want two different threads trying to access the context at the same time. So it's a really good thing that this is all running on the main actor. Pretty cool with that. All right, let's try again. And sure enough, there it is. It loaded the two that we had in our bundle. That's these two things right here. This one and this one. We changed their names in here to be Mastermind JSON and Undersea JSON. And that's exactly what we're seeing here. And it even has the two attempts we made. So our saving and reloading of the files is working even with the extra attempts. So that's kind of fun. All right, that's all I wanted to show you there. This kind of whirlwind version of accessing the file system and making things codable and all that. But hopefully it's give you a guide so that you can go do this in your app if you need to. Now, a lot of you in your final projects are just going to use SwiftData to store stuff. Absolutely fine, no problem with that. But if you, for some reason, think you wanted to make something codable and write it out to the file system, you know how to do that as well. And also, as I told you in SwiftData, if you have some var that's not eligible to be in an at-sign model, but you want to put in SwiftData and you don't want to make it an at-sign model, and you don't want to do the string conversion we did, like with kind and underbar kind, then it is an option just to add codable conformance like this to it, and then add it as a var in your at-sign model. It automatically puts it in there as a data and restores it for you automatically. All right, that is it. That is the end of all lectures in this class. You finally made it to the end. All that we have left is to do your final projects and your final project presentations next week. So great luck with that. And as always, you guys know how to ask questions on Ed, and don't be shy about doing that. And we'll have office hours, of course, all next week as well if you want to come talk to us in person.